In this lesson, you'll learn about the Herald's Concordance Index to evaluate the performance of survival models. You've already worked with and calculated the regular Concordance Index before. You'll learn how this calculation can be modified when you are working with survival data. This final tool will allow you to evaluate the survival models you've now learned about. In this lesson, we'll chat about the evaluation of survival models with the Herald C-Index. We've already seen the setup of evaluating a prognostic model. We asked how good a prognostic model was earlier when we were looking at a setup where we had a risk of death within 10 years, or where we were looking at cardiovascular disease risk prediction in 10 years. And there we had this outcomes of yes or no for death within 10 years, and we had a model output a risk score. And we saw the C-Index, which looked at pairwise comparisons and looked at how many of the pairs were concordant, how many of them were tied, and divided by the total number of permissible pairs in those pairwise comparisons. Survival models have two main differences to the setups we've seen earlier. The first difference is that the ground truth, the thing we're caring about modeling, is the time to the event, and we'll call that a capital T, where for patients we have a time to an event like 30 months in this example. And the second key difference that we have with survival models in our data is that we have censored observations, and we need to think about in our evaluations how we can handle these censored observations as well. So first, let's look at the idea of concordance again. Concordance was the idea that the patient with the worst outcome should have a higher risk score. And now we can think about, in time to event problems, what does worst outcome mean? And we can see that a worse outcome would be if a patient had an event earlier. So for example, if this patient had an event at time 20 months and this patient had an event at time 40 months, the worst outcome was for the patient who lived a shorter amount of time. And so for this patient, we should have a higher risk score. So this would be a concordant pair because it does follow this rule. But let's look at what happens when our time to event is the same. Now, when our time to event is the same, we'd want an ideal risk score to say that the risk for both of them is the same. So this would be another case which we would now call concordant. Let's say we had two time to events that were different, but the worst outcome was for one who got the lower risk score. In this case, this patient. That's a problem. So this is a not concordant pair. Here's an example of a risk tie where we have two different time to events, but we have the same risk score. And if we have the same risk score for two patients who had a different time to an event, this would be an example of a risk tie for those patients. This is also an example of a risk tie where we have two patients with the same time to an event, where we're saying that the risk score for one of them is smaller than for the other. And here we don't want to fully reward the risk model because the time to events were the same. So ideally we should have had the same risk score, but it's not entirely wrong either. So we'll call this a risk tie.